My name's Dave Hayden. I'm the Application Engineering Manager for the Industrial segment for Stratasys. We're here with Great Western Railway. They've been using our FDM technology to both prototype and make production parts for their new battery electric train. Great Western Railway is really innovative because not only are they making one of the world's first battery electric trains, but also they're using Stratasys FDM to make some of the pieces for this vehicle.
My name is Julian Fletcher. I am the Technical Development Manager at GWR. Battery trains have their place in decarbonising the railway. I think within the industry it's clear that electrifying all the lines is the sort of gold standard, but that is very costly. Logistically it's very hard. So then you look at battery trains and say, well, where do they fit in? Over recent years, battery technology has meant that they're viable, and charging technology now means that they're a practical option for shorter branch lines, not for sort of intercity routes.
One of the things we were able to support this customer with was mechanical performance data for a range of temperatures. So from the minus 54 degrees Celsius all the way up to 145 degrees, we could give them strength, stiffness and elongation of brake values.
So you've got to meet the fire standards for the equipment you're putting on the train, and that's where Ultem 9085 meets our requirement. So we used Ultem 9085 for the covers on the top of the shoe gear system. The design space was really narrow, and if you look at it on the train, it is ridiculous. I probably shouldn't say that, but it was a nice challenge for an engineer, put it that way. Couldn't make them out of sort of bent steel, or casting them was out of the question in our time scales. And so 3D printing, but industrially, was really the answer. These weren't a desktop print job. They had to be done in a controlled way. There's fire regulations to meet, so the material's got to be right, and it's got to be traceable. So that's where Stratasys came in, and as well as the expertise, they meant that we had a controlled industrial partner to be able to work with.
And then the other parts that we made were the driver's screen bezel, where we used our PCFR material. PCFR is a lower cost alternative to Ultem 9085, but it still meets hazard level 3 for the railway fire safety regulations. Great Western Railway are really innovative because they firstly prototyped the shoe gear covers using Ultem 9085, but then actually were able to use the exact same technology for their production parts.
Additive manufacturing is ideal for making a small number of parts. For example, this initial fast charge battery train trial is only going on for 1 year with one train, so we've only needed about 4 parts for this trial, but we will need to expand that later, so it's perfect.